notebook and get these integrations. There are many applications of the integral of a natural log. The formula, of course, is easy, and we already talked about it. So those different version of this formula is going to be your problems, or we have to investigate it. Okay, so there you are. This is going to be 5.2. It's going to be 5.2, and just to make a record that today is Tuesday, 7:25. Okay, so we're going to talk about the integrations that involve the natural log. So you get a couple of questions from this part. Integration, okay, of the log function, of the natural log. Natural, okay, logarithmic function. Okay, there you are. So the situation is clear, or the formula at least, because we already talked about the derivative of this function. So we are going to define equivalently the integral of this function. So what we know so far is this one. Recall that we know that if you want to find the derivative of ln x, okay, derivative of ln x is going to be 1 over x. That's one formula. But if it is going to be anything other than the x, we call it u. So, and if you want to find the derivative of ln u, like the chain rule type, so in this case, derivative would be u prime u. Okay, so this is the formula for the differentiation. You know that any formula for the differentiation can be changed into the format of the antiderivative. So this first one means if you are looking for a function whose derivative is 1 over x, that function is ln x. And the same thing for this one. So we can say that equivalently, if we change it to the other format, so this formula are going to be equivalent to the following. So the first one would be integral of 1 over x. You see, this is the one that we couldn't do before. So you are interested in a function whose derivative is 1 over x. Now, we know that that function is ln x. Okay, ln x, as we put it over here, plus the constant c. But there is going to be a catch here that you got to be careful, and we already prepared for it. What is that? You see, when you write these two, you must make sure that the domain of these two are going to be the same thing. So if you go to look at the left, the function is 1 over x. You know that 1 over x is defined everywhere except when x is 0. But if you go to the right, you get ln of x. Remember, ln of x is defined only for the positive number. So they are not going to be, their domain are not, okay, matching each other, if you like. So what we do is, instead of writing ln x, we always write ln of the absolute value of x. And we already proved it for you. Remember, we proved that the derivative of ln of absolute value of x is also 1 over x, okay? So we did this one as a remark the other day because we knew that we are going to use it. You see this one? So the exact formula can be used even when using the absolute value of x. So since the domain must be the same, so make sure that you put this absolute value all the time, unless you have some information that this x is positive. But write it down with the absolute value of x. Otherwise, on the test, you will miss some points. Okay, and the second one is going to be the same thing. So it's going to be the chain rule type. It's going to be the chain rule type. Of course, it's going to be 1 over u, and this is going to be d of u. The same thing. You want to find the function whose derivative is going to be 1 over u. That function is ln u, but you have to write the ln of the absolute value of u plus the constant c. Okay, so this is the formula that you need for integrating natural log function. Okay, you can add it to the collection of your formula for your test. Okay, any question? Now the formula is straightforward, but the way we're going to apply it is going to be quite a lot. Okay, so let's start with the examples. Read these examples carefully because there are going to be the type of kind of 3-4 types, and all of them would be repeated for your test. Okay, so we start with the ordinary example that we are going to use only the first one. No substitution is needed. Okay, so what we'd like to do, we'd like to evaluate each integral. Evaluate, okay, each integral. The first one is just ordinary function. So we want to find the integral of, let's say, 2x squared. Okay, 2x squared plus 3 over x, 3 over x minus 5. Minus 5 dx. This is the one. Remember, when we want to integrate, we check to see if there is going to be any rational expression. We change it. But look at this one. The power is 1. Now we know it, why we were emphasizing on this one. If this power is 1, you stay where you are because you have the formula for it. If it's going to be anything else, you move it up. If it's going to be x squared, okay, radical x, etc. So if it is x, you keep it. Because if you move it up, that gives x to the negative 1. And you know that you cannot use the power rule. Then you have to use this one again. But make sure you know the difference, okay? So there you are, solution. So we don't need to rewrite it. So simply we go ahead and integrate it. So it's a 2x squared plus 3x minus 5 and dx. So the first part is the usual practice. It's going to be 2 times power up x cubed over 3. Okay, now this one, you're not going to change. It's going to be 3. Okay, it's going to be 3 by integral of 1 over x is ln of the absolute value of x. You see, this is the way you write it down. And integral of a negative 5, of course, is going to be negative 5x plus the constant c. You cannot simplify this one, you just rewrite it. Rewrite it. This is the way I write it. I like to write the coefficient out. So that's going to be 2/3. It's going to be 2/3 x cubed plus 3 ln of the absolute value of x minus 5x plus the constant c. So that gives you simply the final answer. Any question? So we have to look for those 1 over x that you will see them. When it's a 1 over x, natural log. But make sure to put the parentheses here, because this x must be, you must guarantee that x is positive. You see, when you write when we work with the ln x in ordinary cases, we know that the domain is all positive numbers, but these are connected to each other. So they must, you must have the same domain. Okay, that's type 1. Any question? Type 2. Just compare it with the one that you did before. You see, suppose you want to find this integral. 2 plus x squared over x cubed and dx. Now you know that you have to move this one up first, okay, because it's a single term and you did it before. So solution is going to be, that's it. This is going to be your solution. So we have to move it up. So that gives us x to the negative 3 times 2 plus x squared dx. Now you multiply it cross, okay, just moving forward, distribute it. So that gives it 2x to the negative 3 plus x to the, you see it's a negative 3 plus 2. Negative 3 plus 2 will be a negative 1. Negative 1 dx. You see, that's it. Previously, we didn't have x to the negative 1, but now we have it. Okay, so we integrate it. It's going to be equal to the 2 times. Move up the power, so that gives x to the -3 plus 1 would be -2 divided by a -2. Okay, plus. Now x to the -1, you cannot use the power rule for this one, but we know that x to the -1 is just 1 over x. So integral of x to the -1 would be ln of the absolute value of x plus the constant, okay, plus the constant c. So previously we couldn't do it because we didn't have the formula. We can use the power rule all the time, but you cannot use it when the power is -1. So we have to take care of these negatives. The 2 and the 2 would cancel out. There is a negative sign here. So the final answer would be, so this is going to be the final answer. So it's going to be -1 over x squared plus ln of the absolute value of x plus the constant c. So that gave you the final answer. Okay, so we modify what we did before, but we did have some restriction. Now we know it, then we can do it. Any question? So these are the one that you don't need any substitution method. So we're just using this formula that the integral of 1 over x is ln of the absolute value of x. But lots of fun are coming when you do the substitution type. So that was the first one. So the second group of the examples are going to be the one that you have to use the substitution method. And this would be quite a lot. So this is where we get those two questions. Now, evaluate each integral. Evaluate each integral, but using substitution method. You have to, okay, by substitution. So we give it a hint, and automatically, after a while, you can do it yourself. Okay, by substitution. So what's going to be the first one? The first one is you want to find the integral of, you see x squared on the top, x squared over x cubed plus 1 dx. You see it's a quotient function. It's a quotient function as we know it now. You see, if you want to find the integral of a quotient function in this course, if there is any parenthesis here and there is a power, you are going to move it up and you do the u substitution. But if there is no power, you stay where you are. You are going to call this one u, and you change it into the 1 over u. If you change it to the 1 over u, then you know that the integral of 1 over u would be ln u, and then you're done. Okay, so all the time, if there is any power here, you move it up. Then inside parentheses, you call it u, and you do u substitution. If there is no power here, the power is 1. So you stay where you are. You take this one to be u, you do the u substitution, you get 1 over u, and the result would be natural log, okay? So that would be the procedure that we are going to now to follow. So this is it. You are going to take the u to be x cubed plus 1. You see? And then the target is going to be, you see, the target is 1 over u. So, this is going to be u. Okay, so just remind yourself that the target is going to be 1 over u du. So in order to get it, your usual practice, find the du. Differential of the u, derivative is going to be 3x squared, okay, times the dx. Then as usual, you have to find the dx. So the dx would be the du over 3x squared. Okay, go back, substitute, get your target. 1 over u. If you don't get it, you probably missed something. So originally, this is what we have, x squared, and this is x cubed plus 1 dx. Now we substitute. We don't have anything for the x squared, don't worry. But x cubed plus 1 is u, so that would be u. And the dx is du, okay, over 3x squared. Now you simplify it. X squared and X squared would cancel out. You see the top, the leftover is 1. The bottom one is 3. So there is going to be a leftover of 1/3. 1/3, you pull out the 1/3. So that gives you 1/3 integral of 1/u du as we targeted. Any question? So you must get the 1/u because you predicted. Okay, so everything else must be simplified. You may have some extra terms, a constant, just 1/3, put it out. No, there you are. Integral of 1u du is equal to the 1/3. Okay, ln of the absolute value of u. Remember, absolute value all the time. Absolute value of u plus, plus c. But you are not done. Of course, you have to substitute for u. So this is going to be equal to the 1/3. Okay, it's going to be 1/3 ln of the absolute value of x cubed plus 1 plus the constant c. So that would be the final answer. Any question? So it's very easy to recognize this integral because of that bottom that I talk about it. There is no parentheses. We call it u, and automatically you get the 1/u. So this is going to be the type 1. Any question? Now I want you to compare them together because these two questions would be given usually. So look at this one. I'm going to repeat this one again, but I changed the bottom. You see that's a number 2. This is x squared. Okay, the bottom one is the same thing, x cubed plus 1. Okay, but I raise it to a power like 4 dx. So you will see both of them, okay, from time to time. So you should recognize the difference. So as I talk about it, this one, because there is a power here. So we're going to move it up first, as usual. And then inside parentheses, of course, going to be u, and you do the job. But the other one, look at this one. There is no parentheses here. There is no power, extra power. So that's why we stay there, because we end up with the 1/u. But over here, we move it up, we end up with the u to the -4. Okay. So I just want to see the difference. And there's not going to be any other type of the integral when you do this rational function. Okay, so let's do it. You have to rewrite it. You rewrite it, you are going to get what? It's going to be x squared, x cubed plus 1 to the -4 dx. So this is the one that you have to find. So the inside, you call it u. So the target is going to be integral of u to the -4. U to the -4 and du. You must end up with this one when you do the substitution. Okay, so for the previous case, you better not to move it up. This can be done easily. But for this one, because there is a power here, you have no other choice. You have to move it up, okay? But the rest of the procedure is going to be the same. So we have the u, which is going to be x cubed plus 1. So we have to find the differential of the u. Okay, differential of the u would be the derivative, which is a 3x squared times the dx. Then we have to find the dx. And the dx, of course, is going to be du over 3x squared. Okay, so this is it. Go back, substitute. You substitute here. If you don't want to repeat it, you can call it I or just rewrite it. So this is it. So I'm going to deal with the x squared, x cubed plus 1 to the -4 dx. So this is going to be equal to integral of, there is nothing to be done with the x squared. So this is u, so that gives you u to the -4. Okay, u to the -4 and the dx. And the dx is what? Is du over 3x squared. Any question? Again, these two would cancel out. The leftover is 1/3. 1/3, you move it out, and then you have your target. So it's going to be 1/3. Okay, 1/3 integral of u to the -4 and du. You see, as you predicted. You must get that one. Now that's it. That would be easy. So it's going to be equal to the 1/3 power up. It's going to be u to the. It's a -4 plus 1 would be a -3. Okay, over the -3 plus the constant c. So you have to take care of these. 3 times 3 would be 9. So this is going to be equal to a negative. On the top we get 1. Down the bottom we get 9u cubed. 9u cubed plus c. So this is going to be equal to the -1/9. You have to substitute for u. What is u? U is x cubed plus 1. So it's going to be times x cubed plus 1 cube, of course, plus the constant c. So that would give you the final answer. Okay, so this is the way you should expect this type of questions. Two different versions. The version that you have a power, and the version that the power is 1. This would be one of those case that we are going to be interested in, and in any test, any quiz on these topics, this would be one of the cases that you are going to be interested in. Okay, any question? But sometimes they want to make it more exciting for you. They may give you the same thing, but it's going to be a kind of with the trigonometric function. So let's see what would happen to the trigonometric function. Okay. Again, this format is popular. So what's going to be the trigonometric version? This is it. You want to find this integral. Look at this one, integral of. The top is secant square of x. The bottom one is 1 plus 10. 1 plus 10x dx. See, this is a very easy question, but you have to, give us all the details. Again, is a rational function. There is no power here, no parentheses here. So what we have to do is we have to take this one to be u. Okay, we take this one to be u, and the target is going to be 1/u du. You see, that's going to be what? Okay, but this one can be done by a shortcut, really, short form. You see, this is 1 plus 10x. What's going to be u prime? U prime would be secant square. It's already on the top. So it's of the form of u prime u. You know that u prime u is just the derivative of ln u, ln of the bottom, and done. But in this course, we try to practice the u substitution form, so we go for the full operations. But if we're going to be calculus 2, of course, we do it right away. So the result is ln of the absolute value of 1 plus 10x. Okay, but in this course, give us the details. So there you are, solution. You take the u to be equal to the 1 plus 10x. That's a part 1. Differential of the u, derivative. Derivative of 1, 0, derivative of a tangent secant squared. Secant square of x, but times it by dx. Then you have to find the dx. So you divide by secant square. So your dx would be du over secant square of x. You see, this is the case. Go back, substitute, and show that you get 1/u. Okay, going back, this is it. So originally, we did have a secant square of x, 1 plus 10x, dx. Now we substitute. We don't have anything to substitute for the secant square. Don't worry, it would be canceled out. But the bottom one is the one that you call it u. U dx. The dx is du over secant square of x. Now, as you can see, secant square and secant square would be out. It's going to be 1/u. Some people, they made a mistake on the test. They write this one equal to the u, which is not. It's equal to the 1 over u. Okay, so it's going to be integral of 1 over u du, and this is your target. Integral of 1 over u is ln x, ln of u, ln of the absolute value of u, of course, plus c. Remember, always when you use the natural log, you have to use the absolute value to, okay, to guarantee that this is going to be the case. Okay, so this is going to be equal to, we substitute for u, is going to be ln of the absolute value of u. What is u? 1 plus tan x plus the constant c, and that would be the final answer. Okay, any question? So again, it's very popular. They give you, this is, I give you secant 10. So they may give you cosine 1 plus sine, and they may give you sine 1 plus cosine. These are the possibility. You may be given in your practice one, you have 1 plus secant. So the top is secant 10, because you have to have the u prime, okay? You have to have the u prime on the top, okay? To get these numbers done. So this is going to be the third case. Any question? Now, one of the main application of this idea of a natural log for integration are going to be finding a special integral of the trigonometric function that we were not able to do it. Remember previously we talked about, we know that integral of a sine is a negative cosine. Integral of a cosine is a sine. Then we know the integral of secant squared is tan. But we never talk about the integral of a tangent or integral of the secant. So you will see why, and we're going to do it. Okay, so make sure you know this. And number 4, you can add this one to your collection as a formula, but you should be able to prove it if it's going to be given to you. Okay, so I'm going to find it, then I write it down as a formula. We want to know what's going to be the integral of a tangent x. Integral of tan x. I get this formula, then I give you the actual one that can be done by a substitution method. Okay, so you want to find the function whose derivative is tangent. Couldn't do it before because we don't have such a function. But now we can do it by substitution method. So the solution is going to be, we rewrite tangent of sine over cosine. So it's going to be integral of tan x dx is equal to, okay, it's going to be integral to the tangent. Tangent is going to be sine over cosine. So it's going to be sine x on the top, cosine x on the bottom, dx. Let's say that's going to be the case. Now it's a rational function. There is no power than the denominator. So we can use the u substitution to take care of it. So we take the bottom to be u, be cosine x, and the target is 1 over u again. So if this is going to be your u, you have to give us a du. Du would be differential of the u, okay, differential of the u. Now derivative of a cosine, of course, is a negative sign x, okay, negative sine x, but times the dx. So you have to find the dx. So what's going to be the dx? Dx is going to be equal to, the negative, if you like, du on the top and the sine x on the bottom. Okay, so that would be your dx. There is a negative sign here, which make sure that you don't miss it. Okay, so this is going to be the case. Now go back, substitute. Okay, go back and substitute here to see what's going to be the situation that we have. So the situation is going to be, we are looking for the integral of a sine x over cosine x and dx. So it's going to be integral of, we don't have anything for the sine, don't worry. But the cosine x is the one that we call it u. Okay, then the dx is what? The dx is times it by negative du over sine x. Okay, Now, as you can see, the sign and the sign would be cancelled out, but the top is 1. This negative sign, you can put it out. So you can pull out that negative sign. So it's going to be integral of 1 over u du. You see? And we know that integral of 1 over u would be ln u. So it's going to be negative ln of the absolute value of u plus c. But you have to substitute for u. U was cosine x. So it's going to be negative ln of the absolute value of a cosine x plus c. This is one way to write it down. Some people, this is the way they memorize it, but I prefer to continue. You see, some people write this one as a tan. We accept it if you use it. Tangent of x is a negative ln of the absolute value of a cosine x plus c. This is a standard formula. You can memorize it and you can use it. But I prefer, or this, the way it's more common, it's a ln function. I move this negative to the top. I move this negative to the top. You see, this is going to be the case. That's alternative. Easier formula to remember. Note that. You see, the way I'm going to simplify it is this. This is a negative ln of the absolute value of a cosine x. And so this would be, I move the negative up. It's going to be ln. Okay, ln of the absolute value of a cosine x to the negative 1. Okay, and this is going to be equal to ln of absolute value of 1 over cosine x. At 1 over cosine is secant. Okay, so this make it into the ln of the absolute value of a secant x. So instead of this formula, we prepare this one. Even if you use it, we don't mind. So this is a standard formula to memorize for the integral of a tangent. So tangent x dx is equal to the ln of the absolute value of a secant x plus the constant c. Okay, I just proved it for you, but this is the formula. Then you can add it to your collection and be prepared to use it. I'll write it down as a remark. So this is going to be, I just proved it for you, and that is the case. Okay, so pick whichever you like. And we like the second one, ln of a secant. Integral of a tangent is ln of the absolute value of a secant plus c, or you can go with the negative ln of the absolute value of a cosine. Okay, so I make it as a remark so that you add it to your collection. So this is going to be, that's why we waited, because we couldn't do it, you see. And that's why we didn't give you any example involving tangent before, because you didn't have the formula. Now you have it. This is it. This is what you have to memorize. The tangent x dx. Integral of a tangent is ln of the absolute value of a secant x plus c. That's one version. If it's going to be change rule type, you can replace the x by u. So integral of a tangent of u, d of u. Okay, that's it. The du is going to be the same thing. Ln of the absolute value of a secant of u plus the constant c. Okay, so this is the standard formula that you have to add to collection of your formulas. It's very popular. Integral of a tangent. If you take calculus 2, in most of the time, you will end up with the integral of a tangent. And they expect you to know it right away. As soon as you see it, you can do it. Okay, so this is going to be the case. Any question? So that's another advantage of the ln function. Now, the way you may be question on this one is the following. Okay, so you know the formula, but they change it a little bit into this format. So I'm going to call it example number 5. And this is the case. You may be asked, what is the integral of, let's say, x squared tangent of x cubed dx? You see, this is the way you are going to be questioned. Remember, this is going to be the case. This is not tangent of the x, it's tangent of the x cube. So what you have to do, as you did for the other trigonometric function, you're going to call this one u. So you have to change it into the tangent of u. Okay, so the target is going to be what is integral of a tangent of u du. If you change it, then you have your formula. Okay, so although we let you use the formula, but we may question you of this format. Okay, so your job is just nicely apply the substitution method to get to the target, then you'll be able to do it. Okay, it's at this level, you can't do anything else. This is, this can come with a secant, can come with a sine, can come with a cosine. You can't do anything else in calculus 1. Okay, so this is it. You have to do the operation. Again, all the details of the substitution method should be given on your test or the quiz or the final. So you take the u to be x cubed. That is u. Then you find the du. Okay, the x cubed would be 3x squared dx. You have to find the dx as usual. So that gives you du over 3x squared. Okay, now go back, substitute. If you have done everything all right, you must end up with the tangent of u. So bring the original one, it's x squared tan of x cubed dx. Substitute. You don't have anything for the x squared, no worry. It's going to be tangent. Okay, it's going to be tangent of what? Tangent of u. But you have to multiply by dx, that's your dx. So it's going to be times by du over 3x squared. So the x squared and x squared would cancel out. Left over 1/3. So put it out. So that gives you 1/3 integral of tan u du, as you predicted, you see. But you know that integral of a tan is ln of the secant. So it's going to be equal to, this is your formula. So it's going to be equal to the 1/3. Okay, 1/3 ln of the absolute value of a secant of u plus c. But you have to substitute for u. Your u is x cubed. So the final answer would be 1/3 ln of the absolute value of a secant of x cubed. Okay, plus constant c. So that would be the final answer. So this is the way you are going to use this formula. And by itself, it's easy, tangent ln secant. But you may be given something else, okay? And it's a usual practice for the trigonometric function that you go back and switch it and take care of it. Okay, any question? There is one more that it's going to be used quite a lot. And you can do that one only again when using the natural log function. And that's integral of a secant. So we're going to take care of that one too. It's very tricky. Secant is very popular for application problems, and in calculus 2, you see it quite a lot. So they expect you to memorize it. There are different ways to find it. I just want to give a proof, okay? I find it, again, you memorize it as a formula and you can use it, okay? So that's why our sixth example, the sixth one is, how about integral of a secant? Again, we didn't talk about it before because we couldn't do it. Now, how are we going to do the secant? This is tricky. Okay, there are different ways to do it, but in calculus 1, what I'm going to do is, I would like to change it into a fraction. Then I will try to use that formula, integral of 1 over u du, and the result would be a natural log, and then be done. The way we are going to do it as a trick for this course, of course, you see, this is the given one. So what I'm going to do, I'm going to multiply this one by something nice, and I divide it at the same time. What is that? This is the secant of x. Something nice is this. Something nice is the secant of x plus tangent of x. And at the same time, I divide. Why? Because this is the only way I can do it in this course. Okay, we are going to create that 1 over x dx. Of course, there are some other methods. Okay, so what is the advantage of my operation if you multiply the secant inside? So it's going to be integral of, okay, that's it. So multiply the top, that gives you secant square of x plus secant of x, tangent of x. That's the top. What's the bottom? The bottom is secant of x plus tangent of x dx. That's it. You see now, if you take this one to be u, you see this one to be u, what's going to be du, or what's going to be derivative? You see the derivative of this one? The derivative of a secant is secant 10 plus the derivative of a tangent, secant square. So this is u prime dx. So if you take this one to be u, everything on the top, you see everything on the top here, that gives you the du. So this would be the same as 1 over u du. And you know that 1 over u du would be what? Would be, this is going to be ln of the absolute value of a denominator u, which is a secant of x plus tangent of x plus c. And then do that. See, in this course, we can use only this trick to do it. So this is the formula to remember or memorize. Okay, I just give you as a remark. And you have to add it to your collection and use it anytime you like. So integral of a secant of x dx is ln of the absolute value of a secant of x plus tangent of x and the c. You don't have to prove it because I just proved it for you. But if you have anything other than the x, of course, use substitution. So it's going to be secant of, if you have secant of u du, this would be the same thing, but you'd go with the ln of the absolute value of secant of u plus tangent of u plus the constant c. Okay, so again, this is a set of formula that you needed. So integral of a tangent and integral of a secant. These are going to be the one that we usually practice. And it's very popular, and we expect you to be able to handle it. Of course, not with just the x, okay? Something at this level, again, we can't do anything about it. So I give you something similar to the one that we did over here. But this time, I go with the, okay, I'll go with the secant. Any question? So make sure to add these to your collections, and we expect to be able to do it. Integral of a tangent and integral of a secant, because of the popularity and the application in calculus 2. So we want to make sure that you have seen it in this course, and then you are going to be prepared to use it in future. Okay, so I give you something similar to the other one to see how we're going to handle it. So I'm going to call this one number 7. And it's in fact, this is a kind that you have in your book, one of your problem in your book. And you want to find this integral. Okay, integral of, how about integral of 1 over x squared secant of 1 over x. This is in your assignment. You want to find integral of 1 over x squared, secant of 1 over x dx. Okay, it's a secant function. You can do secant x, but this is secant of something else. So what you have to do is we have to use substitution. You take this one to be u. And the target is going to be you change it to the integral of a secant u. And you know the integral of a secant u is ln of the absolute value of a secant uc plus tangent. If you do this one, then you have the formula ln of the absolute value of a secant of u plus tangent of u will do the job for you. Okay, so that's going to be your target. So don't worry about, it seems to be very unfamiliar. I know it's not. Okay, if you take care of it nicely, it would be all right. So your extra job is just the u substitution. You take the u to be equal to the 1 over x. That's your u. Then you have to find the du, derivative of 1 over x. You know that derivative, you can move it up, x to the negative 1 differentiated. Or if you use the quotient rule, derivative of the top times bottom would be 0, bottom top would be minus 1 over the bottom squared and the dx. This is going to be your dx. Okay, it's just a quotient function or just x to the negative 1. Then you have to find the dx. To find the dx, cross multiply. You see, multiply both sides by x squared. So that gives you x squared du equal to the negative dx. You are looking for the dx, so just multiply by negative sign. So dx would be negative x squared du. Okay, a little bit of algebra involved. Just make sure that you're not going to miss anything. Any question? So I take this one to be u equal to the 1 over x. Differential of the u, just derivative. Derivative of the top is 1 times bottom would be 0. Derivative of 1 is 0. Derivative of the bottom is 1 times top, negative 1 over x squared. Okay, now go back, substitute, you must get this one. Okay, there you are. So originally you have 1 over x squared, secant of 1 over x dx. Substitute is going to be integral of 1 over x squared. You don't have anything for this one so far. This is going to be secant of 1 over x, which is u. So it's going to be secant of u times it by dx, times it by dx. What's a dx? Negative x squared du. See? Simplify. This x squared and x squared will cancel out. The leftover is just a negative 1 or a negative sign. You can put it out and you get your target. So it's equal to negative integral of a secant u du, as we predicted. Now we know it from the formula that this is going to be ln of the absolute value of a secant of u plus tangent of u. So you have to switch it to do the extra job to get to the formula that you know it or you have it. Okay, so then of course you have to substitute for u. U is 1 over x. So the final answer would be negative ln absolute value secant of u. U is 1 over x, secant of 1 over x plus tangent of 1 over x plus the constant c. That give you the final answer. Okay, it's a very popular example to get this through. So you see the role of the natural log and why we like it, because it's helped us quite a lot. Okay, help us quite a lot to be able to take care of this. Any question? So this business about the ln and the secant, what's the kind of things that we want to, we want to prove the formula, but knowing the formula is enough, but make sure that you are able to do it by a kind of a substitution type to get these numbers. Now, so that's number 7. Now there is one more group of these integrals that's going to be so important in calculus. Okay, in calculus 2, if you are preparing to take that course, You will see that question 4 times. The way I teach, I use this one, give this one 4 times during the test, during the term, semester. So you may see it in your quiz 1. Okay, you may see it in test 1, test 2, test 3, test 4. So that's why I would like you to learn it, to see it in this course, and I promise you that I'll give you one of them on this next quiz and one on the final, because I want to make sure you know it. Okay, and it's not a difficult integral. You see, this is a kind of real substitution method. So what is this integral? And this is it. You want to find the integral of this function. Integral of, you see, ln x to the 4th, inside the parentheses, divided by x dx. Easy integral. You see this ln x? It can be on the top or can be down the bottom. 2 cases. So what we do, you use a substitution method. Remember the substitution method, anything inside the parentheses, you call it u. In all the problems that you did so far, u was just a polynomial. You see x squared plus 1, x cubed, etc. But not this one. So inside the parentheses, whatever it is, you call it u. Okay, so this is going to be the solution. Inside is ln x. You see, if you take this one to be u, so the target is going to be this one, integral of u to the 4th du. And then you can do this one right away. Okay, that's the idea. That's the idea of the substitution method. So let's do it to see if we can get that. U is ln x. Okay, u is ln x. You have to find the du. Differential of the u is what? Derivative of ln x, 1 over x. But you multiply by dx. But remember, you want to find the dx, so cross multiply. Or multiply both sides by x. If you cross multiply, this is going to be dx equal to the x du. You see? That's all you need. So as usual, you take the inside to be u, which is ln x. Okay. And then you find the du, 1 over x dx, you cross multiply. Go back, substitute, you must get u to the 4th. So let's see if we can get it. So this is the original one, ln x to the 4th over x dx is equal to the, this is u to the 4th. You don't have anything for the x, don't worry. And you do have the dx. What's the dx? dx is x du, x du. You see, the x would disappear. So the result is simply what we are looking for, integral of u to the 4th du. Any question? So we know, we target it, and then we get it. And you know that this is going to be what? This is going to be equal to u to the 5th over 5 plus c. But what is u? ln x. So that gives you ln x to the 5th over 5 plus the constant c, and then you are done. Very popular problem. Any question? In calculus 2, we have something we call as sequences. In the case of the sequence, is a function whose domain is only natural numbers. So they don't use ln x, they use ln n. And there is the result is going to be sequence. So one way that we talk about those sequences, find the limits, n goes to infinity, and this integral would be given to you. This integral would be given to you, but it's going to be something like 1 to infinity. And then you have to take the limit of this function. The limit of ln x when it goes to infinity is infinity. So they don't like this in calculus 2, because the limit is not a number in that case, the limit at infinity. If that would happen, this is what we call improper integral, and we say it's divergent. The one that they like it if this ln is down the bottom. So you may get this one for the divergent, or you may get the other one for the convergent. This is the way you use it in several places. But as you can see, as soon as you identify that, you have to use substitution, and your u would be ln x, then you'll be fine. Be able to get to real and easy integral. And so that's one case. And the last case is going to be, how about if this ln is down the bottom, which is much better for those purposes that we have. So that would be our last example. Any question? To read these examples carefully, and not only for this quiz and the test, but for future if you want to continue taking calculus courses. Okay, so the one they prefer is this one, 1 over x ln x. There are some shortcuts for these, but we would like you to apply your method. That's why I'm not going to talk about it. You see this? Again, do the same thing. You see inside parentheses, call it u. So the target is going to be, if you call this one u, so you have to get this one first. And then we can handle it. We know that we move the u up. So the solution is going to be, the substitution terms are going to be the same. So we take u to be ln x. The procedure is almost similar. Then we have to find the du, differential of the u. Ln x derivative is 1 over x dx. Then cross multiply to get the dx, multiply both sides by x times. So it's going to be, that's it, x times du is going to be equal to the dx. Go back, substitute. So originally you have 1 over x ln x all cubed dx, that's the original one. Now substitute 1. We don't have anything for the x, no worry. Ln x, you call it u, so that give you u cubed. And your dx is x du. Again, you see, these two would cancel out. What are going to end up? You end up with 1 over u cubed du, as you predicted. But you know that since there is a power to integrate it, you have to move it up. So it's going to be integral of u to the negative 3 du. Now, power up, so u to the negative 3 plus 1 would be negative 2 over negative 2 plus the constant c. But you have to take care of it. You see the powers, it's going to be just a negative sign, 1 over 2u squared plus c. Now you substitute for u. U is ln x. So it's going to be negative 1 over 2 ln x all squared plus the constant c. So that would be the final answer. X ln x cubed dx. Okay, so it's both cases are easy cases, but very important one. Okay, so again, that shows you that the u substitution is not the case that you always use it when the inside parenthesis is a polynomial. So it can be anything, especially in the form of this natural log function. This is integration of the log function. Okay, so now you are familiar with the differentiation and integration of the ln function. So you get one question, 2 parts. We are going to ask you to differentiate. And there is going to be one problem that you have to find the maximum minimum. And there's going to be one problem that you have to integrate. So 1, 2, 3. So we give you a break and we come back and we talk about the exponential function. Okay. And that would be again very easy function, but very important in calculus. So we take care of that one too. So the collection of these two are going to be the one that we are going to investigate on that. So we have to talk about that exponential function. And when we are done, we pause. There is one section that we usually we usually cover it in calculus 2 with this book. But since not many people are going to have to take calculus 2, so that's why they they switch the sections, and we cover it in calculus 1. So that would be finding it's going to be in the terminal form like what we did at the beginning of the course, 0 over 0 or infinity over infinity. But most of the time it can be done, or it's going to be done by this exponential function, the ln function. So when we are done with that, which is section 5.4, we pause, we bring something, I think, from chapter 6. We talk about it, and we are going to question you, okay? And then we come back and we do the last part of the course, which is inverse trigonometric function, okay? So let's say we plan to do the exponential function today. Okay, so it's 9:06, you've got 15 minutes. So we come back at 9:20, and then we continue and we take care of the natural exponential function, which is quite interesting. It's the topics. Okay, see you then. Okay. So we are going to take a natural log function, okay? Exponential function. It's a 5.4. We assume that you are familiar with some of those properties of these functions. And if we need anything, we are going to, refreshing your memory. And so it's a 5.4. 5.4, and we're going to talk about the natural exponential function. So what's going to be the natural exponential function. That's it. Again, in algebra, we usually talk about this one first, and then we change it to the log function as an inverse. And now in this course, we talk about the natural log first. So we are going to take that, the inverse function, okay, the inverse function of a natural log that happen to be exponential function, okay? So this is the way we're going to define it quickly. So the natural exponential function okay, natural exponential function is going to be denoted. Okay, it's going to be denoted by y equal to e to the x. Okay, the base is e, or not in this course, but sometimes in some cases they write y equal to the exp of x. We are not going to use this notation, of course. And if you see it somewhere, and it's going to be the case, you know that the e is going to be the Euler constant, which is going to be almost, that it's a irrational number, and it's like the pi. You can estimate only the value of the e, okay, and this is going to be a constant, okay, is a constant. Okay, so it's going to be the case. So the natural exponential function is y equal to the e to the x when e is just a Euler constant, and it's going to be defined as the inverse of a natural log, and is defined, okay, defined by, it's going to be definition that y is equal to the e to the x. If you solve for x, for example, that gives you x equal to the ln of y. It's the quickest way, to define it, a relationship between these two functions. Okay, so we already got all the information regarding the one to the right because it's a natural log, and then we can drive the same information for the exponential function by looking at the natural log function, which is going to be the following. Okay, you are familiar with all of them. So I'm going to call this one properties of this function of f of x equal to the e to the x. And we get all properties from, from this information that we have over here. Okay, the first one they're going to be interested in is going to be domain and range. Domain is going to be the possibility for x. So possibility for x, you just look at where x is coming from. Okay, x is coming from as a range of the ln function. We talk about the range of the ln is all real numbers. Or beside is e to the x. X is a polynomial, and the domain of each polynomial is going to be all real numbers. So the domain is free, is going to be all the real numbers, r, or d is equal to the negative infinity and positive infinity. So there is no restriction on this function. It's always defined. But the range is going to be possibility for the y, where the y is coming from. Y coming from ln y. You know that the input of the ln, natural log, cannot be negative. So this y must be positive all the time. Is one way to look at it. The other one is just exponential function. E is a number. E is a positive number. If you have a positive number raised to a number, the result is always positive. So the range of this function, okay, the range of this function happen to be positive numbers only, positive number. Okay, so this means e to the x is never negative. E to the x is always a positive number. Okay, this is going to be one property. The other one is regarding the rules of the exponent. You are familiar with these rules, that e to the 0, for example, is equal to 1. If you multiply e to the x1 times e to the x2, if you multiply with the common base, we carry the base, which is e, and you add the top together. So it's going to be x1 plus x2. Okay, that's a product. If you divide, if you divide e to the x1 over e to the x2, you divide it with the common base, so it's going to be e to the x1 minus x2. Again, there are some places that we may have to use it, so we want to make sure to remember it. Okay, and the other one is, if you have the old power, e to the x1, and then you want to raise it to a new power. So if you get a multiple powers, you multiply them together. It's going to be e to the x1 times e to the x2. Okay, they are all properties from there when we talk about these functions in algebra. Okay. Now, this is one property that we have. There are a couple of properties that we are going to use from time to time. So these are all algebra. Now, the calculus part, which are going to be interesting and we are going to use, is this one. The property that you remember all the time is that e to the x, as we talk about the range, but I just emphasize again, e to the x is always positive. It's going to be always positive because e is positive number. That's one. The other one is that if you take the limit of e to the x, okay, because the domain is negative infinity to positive infinity. So the limit of x e to the x when x goes to negative infinity is going to be equal to the 0. And the limit of e to the x when x goes to positive infinity would be a positive infinity. So we're going to use this from time to time. And e to the 0 was 1. Okay, and if you use your calculator roughly, if you want to get a graph of this function to remember it, this is going to be the case. See, e to the 0 is 1. So this means this is going to be the intercepts, okay, 1. And this is a negative infinity, and this is going to be a positive infinity. So as x goes to negative infinity, so getting closer and closer to the 0. When x goes to positive infinity, this would be just positive infinity, which is up, up, up. So roughly, this is going to be the graph of the exponential function. Okay, and you can use your calculator to graph it, and probably you have seen it before. Okay, so it's a kind of increasing function. It's going to be increasing function. Okay, so f of x equal to the e to the x is increasing. Or we say it's exponentially increasing. It's like, when you put money in the bank, you would like to get your money, getting bigger and bigger, the amount. Okay, and if you consider, in kind of the biology, if you think about the growth functions, growth of the cancer cell, okay, coronavirus, etc., these are going to be all model that we use exponential model and we talk about it. Okay, so we have this idea from algebra. But the one that we are going to be concerned with at the moment is the derivative and integral of this function, okay? So this is going to be the number 4. Any question? Some small points, but useful, that we're going to use. But the big one is the next one of the property that we're going to have, okay? And number 4, what is the derivative of this function? Okay. The derivative of the exponential function, the derivative of y equal to the e to the x. So if you want to differentiate it, there are different ways to do it. But with this method that we have, we can use remember implicit differentiation. See, note that according to our definition, when y is equal to the e to the x, this is the same as x equal to the ln y. Now, if you differentiate both sides, if you differentiate it, derivative of x would be 1. But derivative of ln y, remember, it's implicit differentiation. Y is like the u, it's going to be u prime u. In this case, it's going to be y prime over y. If we cross multiply, so that give you y prime is equal to the y. Y prime is the derivative of the function, and the y is just a function. So this means this is going to be equal to the e to the x. So y prime is e to the x. So the derivative of e to the x is simply e to the x. That's why this function is such a interesting and famous function. And this is going to be, okay, this is the only non-zero function whose derivative is the same as the function. You have only one more function with this property, and that's a zero function. Derivative of 0 is 0. But if you want to consider something which is not 0 and the derivative is the same as the function, that would be our exponential function. And that's why we are interested in this function in calculus. So we make this one as a theorem. And that's all we need to be able to differentiate and to integrate. So the theorem is going to be, and that's it. And the first part, derivative of e to the x is just e to the x. Exponential function never change. We say exponential function never change. It's e to the x. Okay, but if you have a u function, okay, as usual, if u equal to the u of x, sorry, is differentiable. If this is going to be differentiable, then chain rule, derivative of e to the u. You see chain rule, composition of two functions. Outside one is exponential function, so the exponential function never change. But the inside one is u, so we have to multiply by the u prime. Okay, which is the same as u prime e to the u. So that would be very important not to miss it. We always say that the exponential function never change, okay? But if it's a x, it's going to be just e to the x. It's going to be e to the negative x, 5x, 6x, x squared. You make sure you multiply by u prime at the same time. Okay, so this is derivative equivalently. Integration. For the integration, the first part would be integral of e to the x dx, just e to the x plus c. Exponential function stay the same all the time. And if u is going to be a function, okay, e to the u du is going to be e to the u plus c, and then you're done. There is a special case that we use in application. If you know this formula would be helpful for you. You see this third one? If A is a number, then integral of e to the ax dx. You see exponential function never change, that give e to the ax. But remember, you have to multiply it. When you differentiate it, you have to multiply u prime. U prime is a. When you differentiate, you multiply by a. But when you integrate it, you divide by a. You see e to the ax divided by a. I gave you this one, remember, for the sine, cosine, tangent, secant. Now you can have it for the exponential function as well to get these true. Okay, this is all you need to know about the derivative or equivalently integration of the exponential function. So always remember the derivative is the same. So the integral is the same. If it's going to be anything other than the x, you have to use substitution. Again, same. A special case, it's going to be e to the 2x, 3x exponential function never change. But since when you differentiate, you multiply by a, in case of integration, you have to divide by a. Otherwise, nothing else to be done. Okay? We like it because of this, the formula for the derivative is going to be easy. Okay. So what we need? We need 3 types of functions, examples, and we give you 3 again from this one. So the first one is just differentiating. The second one is just finding relative max, relative mean, as we did for the natural log. And the last one, integration is very limited. You don't have much to do at this level with the exponential function. And you do quite a lot in calculus too. Okay, so this is going to be the case. Let's see. To see if we can do all of them. And then be done with all these exponential function and the log function. We don't need anything else to cover. Okay, there you are. Example. Find the derivative of each function. Find the derivative of each function. The only thing that you have to know is just the derivative of exponential function is the exponential function. That's it. Are you ready? The first one. Most of them are going to be in this format. F of x equal to 5x cubed times e to the x. Okay, this is the product of 2 functions. The first function is this one. The second function is exponential function. So you have to apply the product rule. Derivative of the first times second plus derivative of the second times first. Derivative of the first one is easy. 3 times 5, 15 x squared times second e to the x plus. Derivative of the second times first, e to the x. Derivative of e to the x is e to the x. So we get the same thing. Okay, so this is going to be the solution. Remind you that you have to apply the product rule. So that would be the derivative of the first times second plus derivative of a second times first. Just remind yourself. So f prime of x equal to 3 times 5, 15, 15x squared. That's the derivative of the first one. Times it by the second, e to the x, plus derivative of the second times first. Second is e to the x, would be e to the x, so nothing will change. That's it. You see, that would be the end of the problem. You can't do anything about it. Some people try to simplify and you can't do it because they are not like terms. Okay, and you don't need to factor it because you are not going to do anything else with this. So that would be the end of the problem. That's type 1. Any question? You don't need the substitution method or the chain rule for this one. Second one, there are only two groups. The second one is this one, g of x equal to what? E to the x cubed minus 2x. You see this one? You see, this is not e to the x, it's e to the something else. So what you have to do, keep in mind that it's something else. So we're going to call this one u, and then you have to find the e to the u. Now we have to apply the chain rule. Exponential function would be the same, but we have to multiply by u prime. That's the difference between the first group and the second group. Okay, so there you are. It's going to be g prime of x solution. We get the g prime of x equal to exponential function going to be the same, times it by, open a parenthesis, u prime. U prime, derivative up the top, 3x squared minus 2. And then you're done. Again, you can't do anything about it. That would be the end of the problem. Okay, so the number of the cases that you have are going to be very, very limited for this type of differentiation. It's not like the ln function that you have many, many possibilities. Any question? Now this next one is important because it's the one we use in application problems. Like, you invest money in your bank, okay, in your account. You may start with the $1,000 and the bank will give you 4% interest. And after a while, you would like to know how much money do you have in the bank. You probably have done this type of modeling in college algebra or pre-calculus. But in this course, we are going to just finding what is going to be the maximum money. So when your money in the bank is going to be the largest. So we're going to be interested in those optimization problems. So this is the type that we're going to use, okay? So this is f of x equal to, this is a kind of a revenue function that we use in business or in everyday life. So it's 100x e to the negative 0.02x. So from time to time, you may see this type of problems, especially with these decimal numbers. You see, that the decimal numbers, because that's going to be a kind of rate. It's a percent. So 2% just happen to be this one. Now, to differentiate it, this is the full menu, if you like, full course. It's a product rule. So we have to apply the product, which is going to be the derivative of the first one. And this is going to be the second one. So it's going to be the derivative of the first times second. Derivative of the first times second is easy because 100x would be 100. So this is going to be your solution. Okay, f prime of x equal to derivative of the first one, of 100x, 100, times the second function, negative 0.02x. That's the derivative of the first times second, plus second first. Second is exponential function, never change. Exponential function is exponential function. You see, but you have to pay for it. Remember, this is not x, this is u. So you have to multiply by u prime. So you open up the parentheses, u prime. The derivative of negative 0.002 is going to be negative 0.02. Some people, they miss this one, u prime. Okay, derivative of the first 100 times second. Second one, exponential function, of course, never change. But you have to multiply by u prime, the derivative of the top, which is negative 0.02. Then multiply by the first. The first is 100x, 100x. Okay, but we are not done. You have to multiply these two together, and they are monomials, remember? We put the monomials up in front. So the final answer is f prime of x equal to is 100 e to the negative 0.02x. Now multiply this together. It's going to be 200. We have two decimals, so it's going to be minus 2x e to the negative 0.02x. This is the way you write it down. You have to simplify it. You simply, some people, they leave it as is. No, it's not. Remember, we talk about it. Anytime you have these monomials, you have to multiply them together and put it up in front as a, as a coefficient, if you like, of the, or as a monomial, right at the beginning. Any question? So this is the most popular one when you're dealing with this type of. Otherwise, you don't have anything else. Some people, they make it complicated integration, differentiation. No, and these are the most that you need to be able to, to take care of when we get to this exponential function. Question? No. We are very much interested. We talk about this is the revenue function in calculus, in business. They have something they call it supply demands. It's going to be the same type of operations. So this expression is going to be used in application quite a lot, even if used in a statistic. So we would like you to be able to handle this type of model, mathematical modeling for future. So we are going to focus on one of them, and we ask for the relative maximum or relative minimum. Okay, so we did a similar problem for the natural log. So we are going to have a similar problem for the exponential function. As I talk about it, you get one from each on the next quiz and one from each on the final. Okay, pay attention. This is a kind of a unique one because there's going to be one case that we're going to consider, and this is going to be the one. Okay, it's not a difficult problem. Just remember, let me write it down, and this is going to be example. So that would be a kind of application problems or application of this exponential function. So what we'd like you to do is we would like you to find the maximum and the minimum, all relative. Okay, all relative extrema. Means just check to see if there is any maximum, find it, any minimum, find it, of this function, of the function. The function would be of the form that I just talked about it. And this is one of them. You have a number of them to practice. You see them in that quiz that I posted, practice quiz, and of course in your final. Okay, that would be the function that you want to maximize or minimize to get through it. Okay, we did this type of problems before. We know the procedure. We start with the domain of the function. Then we differentiate it, let it equal to the 0 to get the critical values. Then we drop back the critical values into the function. You plug in to find the candidate for the maximum or a minimum. But then you have to test it. You have two possibilities to test. You can use either the first derivative test or the second one. It's up to you, whichever is going to be appropriate. I'm going to show you for this problem which one is appropriate. If you like it, you take it. Otherwise, you go to the other test. Okay, so you have to give us all this procedure to do it. So very standard question, and get practice, and you're not going to miss it. So we start with the domain. Domain, you say exponential function, the top is negative x squared, which is a polynomial. Everything else is a polynomial. So the domain is real numbers, but you have to mention the domain. So the domain of this function is going to be all real numbers, or a negative infinity to positive infinity. All of them. That's a domain. It's type step one. Step two, you have to differentiate it. And this is where you have to be careful. When you want to differentiate it, make sure to apply the product rule. Okay, because these two functions, the first function is a 4x and the second function is exponential. Okay, so we differentiate it, f prime x is equal to div of the first times second. If the first is 4x, div of the 4x is 4, of course, 4 times the second function, negative x squared. That's div of the first times second, plus div of the second. Second is exponential function never change. But we have to pay for it. Remember, u prime. U prime derivative of the top. Derivative of negative x squared would be negative 2x. Negative 2x. That's derivative of the second one. Okay, exponential function never change. But since this is not x, it's going to be anything else. You have to multiply by u prime. That's derivative of the second one times the first one. Times it by the first one, 4x. Okay, that's where you got to be careful. Then you have to simplify it because you want to let it equal to 0. The simplification would be you multiply the monomials. Okay, multiply these two together. So negative 2x times 4x, make it a negative 8x squared, and you put it up in front. So your f prime of x is going to be equal to the 4 e to the negative x squared. And over here is going to be minus 8x squared e to the negative x squared. Okay, so that would be the derivative of the function. Since we want to let it equal, so this derivative, just take a derivative as is. That's a derivative. Okay. The next step is you let this derivative to be equal to 0 to be able to solve the equation. Okay, so let it to be equal to 0. Then we have to solve this one. 4 e to the negative x squared minus 8x squared e to the negative x squared equal to the 0. You see, you have to solve this equation. In order to solve this equation, you have a chance of factoring, you see. For all these problems, as soon as you differentiate it, because the exponential function never changed, so you can factor out the exponential part, e to the negative x squared. As soon as you factor it out, you can handle the leftovers. There are some other terms to factor, it's up to you. But I usually only factor out e to the negative x squared. So I put it out. So the leftover is what? 4 minus 8x squared equal to the 0. Okay, so always factor out that exponential part. Now that is interesting because it's a product equal to the 0, either the first one equal to the 0 or the second one equal to the 0. But you know, e to the negative x squared equal to the 0, never. Never, because we talked about it, exponential parts never 0. E is 2.7. So you never make this one into the 0. So the second part must be 0. Okay, so it's a 4 minus 8x squared equal to 0. Then you solve this equation. Any question? It's always the case. You always have the chance to pull out the e to the negative x squared out. You take it out, you let it equal to 0, you get impossible. So you get a chance to go ahead and let the other part to 0. Now we can solve this one. You know, that's easy. 2 terms, you can do the factoring or just move 4 to the other side. Okay, so your x squared would be a negative 4 over negative 8, which is 1/2. You can take the square root, so x would be positive negative radical 1/2. Okay, you can use your calculator if you like. And if you don't like to use calculator, you have to simplify it. So it's going to be positive, negative, radical 1, radical 2, radical 1 is 1. So positive, negative 1 over radical 2. Okay, again, you can stay with this one, or you can rationalize it. The safest thing is just use calculator, would be easier, but not a big deal. Okay, so that gives you positive, negative, radical 2 over 2. So this is going to be what? This is going to be your critical numbers. Remember, domain of the function is a set of all real numbers. So both of them are going to be critical numbers. So we are going to have two critical numbers. So the critical numbers are going to be negative radical 2 over 2 and positive radical 2 over 2. Any question? Now you have to drop them back into the function and then test them. So that was the second part. This first part, you just find the derivative. The second part, you let the derivative go to 0. Most of the time, you get only one critical number, but in this case, you get two. So you have to put it back into the function, plug in the function. So find f of negative radical 2 over 2. Again, you can use your calculator. It's going to be 4x. Remember, that was 4 times x. So I substitute here. So it's going to be 4 times negative radical 2 over 2 e to the negative radical 2 squared. Okay, again, calculator or just do it as is. And so these two would cancel out. So that gives negative 2 radical 2 e to the radical 2 over 2 squared would be 2/4, which is a 1/2. So that gives you negative 1/2. Okay, negative 2 radical 2 e to the negative 1/2. You can use your calculator to estimate it. Okay, if you estimate it with your calculator, I've done it before, but just want you to, radical 2 is going to be 1.4. So we can do it. You get, I think you can check it. You get a negative 1.7. Okay, so f of negative radical 2 over 2 is going to be negative negative 1.7. Okay, and if you do positive f of radical 2 over 2, you just miss this negative sign. So that gives you positive 1.7. Okay, you see this is going to be two values. So these are two candidates for the maximum or for the minimum to get these numbers through. Any question? Now you have to test it. You pick a test, you have two choices, first derivative test and the second derivative test, to check to see which one is the maximum, which one is the minimum. Okay, you may say, oh, this is negative, it's the minimum, this is the maximum, but you have to test it. You have to give us a reason. For this type of problem, you just look at the derivative, you see the derivative is this one. So the second derivative is not going to be a good choice. First derivative is much easier choice to talk about it. So I suggest that the first derivative test for these type of problems, okay? So I'm going to the next page. You have to test it, remember. So testing. So for this one, we just look at the derivative of the function. You see f prime. If you just pull out that we did it, see it's going to be f prime. 4 minus 8x squared. That's your f prime. You see, if you want to do the second derivative test, it would be more complicated, but you can use the first derivative test. Because for the first derivative test, remember, we look at the sign of the f prime, which is very easy to find because e to the negative x squared is always positive. So we're just checking the sign of the quadratic expression, and you know the short form for this one. Okay, so first derivative test is the suggestion for these type of problems. So you need a chart. X, domain negative infinity to positive infinity. Critical values that you want to test. Negative radical 2/2. Okay, and the positive radical 2/2. Your derivative, f prime, and your function, f of x. Derivative is 0 at two places. And this is negative 1.7 f, and this is 1.7. You see, as I talk about it for the sign of the f prime, e to the negative x squared is positive. You can ignore it. You have a polynomial. Remember, we talk about it for the polynomials between two roots. The sign is opposite sign of the x squared. Sign of the x squared is negative, so the opposite would be positive. Everywhere else is the same as the sign. This is from algebra. If you don't like it, just check numbers. If you don't like this method, you have to check numbers 1, 2, 3 numbers to find out what is the sign of 4 minus 8x squared. For example, if you pick the 0 here, you see 0 that give a positive 4. If you put the positive 1 here, positive 1, that give you 4 minus 8, which is negative. If you put a negative 1 here, that give a negative. So, you have different choices. If you want to check with the numbers, you check this in the derivative. You don't have to, because it's okay. So these are other options. So negative means that the function is going down. Positive means going up. Negative going down. So down, up, this is a minimum. Up, down, this is a maximum. That's it. So, it's clear that f of negative 2 is, you don't have to write it down, but I just write to explain this. This is a relative minimum, and f of radical 2/2. 1.7 is a relative maximum. Okay, it's usually just 1 point, because I give you e to the x squared, you get 2 points. But it's a nice problem, and very, very important in applications that we have from the exponential function. Okay, you have a kind of 4 in that practice quiz and the final review that are posted for you, and we do all of them before getting to the final. And of course, you are going to get your extra 4 in that you will see one of them again. So this is one of the candidates for the optimization problem for the final. Okay, we did a couple of one for the natural log the other day, and this is a similar one for the exponential function. Okay, any question? So the way the people they missed it is when they want to find the derivative. Okay, this is where they usually miss. You see the f prime. If they have the first time, second, they have nothing to worry about. But when they do the second first, they miss the u prime. So make sure that this is e to the negative x squared. So you have to multiply by u prime, which is the negative 2x. Then when you want to let it equal to the 0, make sure you remember, always factor out the exponential. When you factor it out, you can drop it because it's never 0. So the rest are going to be just a kind of a polynomial type, and you'll be able to handle it easily. But otherwise, nothing else to be worried about it. Okay, so this is optimization problem for the exponential function. To finish it, we have to give you a couple of integration one. Okay, so you get a question on integral as well. So this is it. This is the last group of the example for the exponential function. Integrate. Integrations are easy. There is one that we use for application in science. You've got to be patient, otherwise nothing to worry about. Okay, there you are. Evaluate each integral. Each integral. Just, you know that the only formula that you need is this. Integral of e to the x dx is just e to the x. And integral of e to the u du, exponential function never change. You see, that's it. So there are not going to be very different possibilities. Okay, the first one, very ordinary. 2x plus 5 e to the x dx. No substitution is needed. So integral of the first part is just 2x squared over 2 and 5 times e to the x. Okay, so this is easy. Integral of a 2x plus 5 e to the x dx. 2 times power up x squared over 2. 5. You see, integral of e to the x is just e to the x. Never change, like differentiation. The only thing that you do, you simplify these two. So the final answer is x squared plus 5 e to the x plus c, and be done. That's a type 1. Any question? The integral is going to be not difficult. And the one that is going to be more fun is when you need a substitution method, and this is only a unique case. You have this one in your practice one that we posted. It's not x, it's x squared. You have to use your substitution. You must know it automatically. So you change this one to the u, and the result would be e to the u du, which is e to the u plus c. Okay, so for this, you have to use substitution method. Take u to be x squared. So this is the one that we are going to call u. So the target would be e to the u du. This is the plan. Okay, u is equal to the x squared. So the du would be 2x dx. We find the dx. Dx is du over 2x. Go back substitute, automatically you get this one. Okay, taking this. So integral of x e to the x squared dx equal to, we don't have anything to substitute for x, no worry. E to the x squared, what's x squared is u. Times the dx, what's the dx? Dx is the du over 2x. There you are. X and x would cancel out. Left over 1/2. Put it out, you get your target. 1/2 integral of e to the u du. See? Integral of e to the u, just e to the u. So that gives 1/2 e to the u plus c. You substitute for u, which is x squared. 1/2 e to the x squared plus c. And then you're done. Okay, you cannot do much about this integration in calculus 1, but of course you do quite a lot in calculus 2. Okay, so this is going to be number 2. Any question? Now, the one that we use in science is this following problem. In your review, we have a couple of them that you want to find the average value, and you end up with this one, and with the shortcut that I gave you, you can do it right away. You see, this is it. We want to find something like integral from 0 to 100 is a kind of a definite integral. And that's a 50 e to the negative 0.02 x dx. So can, we use in application quite a lot. Sometimes, you invest money in the bank. After a few years, you get some interest. But then you should go back and think about it. You see, because of inflation, the thing that you could do with the $4,000 5 years ago, you cannot do it because you have to pay more if you like. So they have some expressions for the appreciation of your investment. Means, the value of your investment, you invest, it's going to be down if you like. So there is a formula that you can identify the percentage that you lost or percentage you gain. So you end up with this type of integrals that you have to find it. It's an exponential part, and it's going to be negative because you're losing money. So in order to find it, you have to use your substitution to get it. But this is just a constant. Remember the formula that I gave you? If you want to find the integral of e to the ax dx, it's just a number, nothing else. And this is x. So exponential function never change. But you have to divide by u prime. U prime is a. You see, that's formula that you can use quickly and get these problems done. Just because it's a number, u prime. Because when you differentiate this one, you multiply by 0.02. But when you integrate it, you have to divide. So make sure you use these methods to take care of these type of problems. Otherwise, it's going to be messy. I mean, you can do the substitution, of course, but it takes times. And why not? We know it. So this is it, integral from 0 to 100, 50 e to the negative 0.02x dx. You can pull out this number out, 50, make room for your integration. 0 to 100 e to the negative 0.02x dx. Okay, now use the formula. Because your prime is 0.2 only, negative 0.2. So it's going to be 50. Exponential function never change, so just repeat it. Okay, you repeat it, that's going to be e to the negative 0.02x divided by u prime. It's going to be negative 0.02. But remember, you have to find it from 0 to 100 because it's it's definite integral. Any question? You see, easily we can find it. If you do the u substitution, get the same thing, but it's easy and it's clear. Okay, now you have to simplify this nicely. You can use your calculator. If you want to do it yourself, this is going to be the case. You bring this one out if you like, and then they start substituting. So this is going to be kind of negative. You get a 550, and this is going to be 0.02. Okay, this is it, 0.02. Then the left is going to be e to the negative 0.02x from 0 to 100. Okay, this is 0.02. You can put 2 zeros on the top, that make it 5,000. 5,000 divided by 2, that give you 2,500. Or just use your calculator. It's going to be negative 2,500. Okay, this is how you simplify. Now you substitute. So we substitute 100 first, negative 0.02 times 100 minus e to the 0. Okay, I substitute x to the 100 first, then I get the x equal to the 0. So this is going to be negative 2,500 times e to the, if you multiply this together, that give you 200, and you have 2 decimals, so that give you e to the negative 2 minus e to the 0 is 1. Okay, so basically this is going to be negative 2500. Then you can use your calculator to get these numbers. And, you can write them as 1 over e squared minus 1, or just using calculator. We don't accept this one. You have to use your calculator and give us the numbers. So if you use your calculator, I have the final answer, but check it for yourself. It's 2161.6. And there's going to be, they talk about dollars, miles, etc. Then you have something to explain. But eventually we proved that as 0 to 100, 50 e to the negative 0.02x dx is 2161.6. That gives you the final answer. I can just show you the type of problems that you may see in your future discipline, if you like. So you know how to handle it regarding the exponential function. Okay, so you better use this shortcut for these type of problems. Okay, and when the exponent is just 2x, 3x, ax, and then you'll be able to get it right away. Okay, so this is the type of exponential function we have. Any question? So we're going to check this again. We have them when we get to the when we get it to the review. Just I give you one more to just get to know the last group of this type of function that we have. That's a 3 and the 4. And there are a group of problems of this form. Just want to know how you are going to handle it. In the review is e to the x divided by this radical over here is a product. It doesn't matter. You know that when you integrate the radical function, you switch the radical. That's it. You do it. You do it first. You rewrite it. Okay. So it's going to be e to the x 3 plus e to the x to 1/2 dx. See? And you know that. You have to use substitution. Anything inside there, parentheses, we call it u. That's it. And if you do the job all right, you must get u to the 1/2 du. I just want you to see that, it's a substitution method. In the previous problem, you see the inside was ln x. In this case is 3 plus e to the x. No problem. Just continue with your procedure. That's a 3 plus e to the x. This is your u. You find your du. Lift of 3 is 0. The lift of e to the x, just e to the x times dx. Find your dx. Your dx would be du over e to the x. Go back, substitute to get u to the 1/2. Okay, substitute here. So we have integral of e to the x times 3 plus e to the x to the 1/2 dx. So e to the x is just e to the x. 3 plus e to the x is u to the 1/2. And the dx is simply du over e to the x. Now e to the x and e to the x would cancel out. And you get the target, u to the 1/2 du. Okay, so don't be afraid of when they give you the expressions, is e to the x and then inside the radical. No. Now you know it. It's going to be u to the 1/2. 1/2 plus 1 would be 3/2 over the 3/2 plus the constant c. Use the reciprocal. make it into 2/3 u to the 3/2 plus c. Substitute for u and you're done. 2/3 u is what? 3 plus e to the x to the 3/2 plus the constant c. That give you the final answer. Okay, so we gave you all the possibilities when you're dealing with this exponential function and the natural log function. So you are always ready to do all the problems on that practice quiz that I gave you, except one of them, one of the problem, which is going to be in determinant form that we talk about it tomorrow. We usually, after this section, we go directly to the 5.5 and we talk about the inverse trigonometric function and we finish the course. But as I told you, the policy has been changed. So we are supposed to cover that in determinant form. I think it's from chapter 6 in calculus 2. So we cover that one tomorrow. Then we give you the quiz on that, and then we talk about that last section. So we have 2 more sections to cover, and we cover it. So by the end of the week, we are almost done. But you have to practice, okay? You need to practice quite a lot. So you have the similar problem on your final review that I posted, and the practice quiz number 4 that I started reviewing on, on Thursday. That's it for today. Any question? So take this, study this quickly, then we review it, and this is it, and we try to finish it, okay? So see you tomorrow. If you haven't done your test, you know that this is the second day. Just try to do it as quickly as possible so I can grade it right away, and then we start moving towards the final review. Let me know if you need anything. Okay, have a good one and see you tomorrow. Bye-bye.